Today's presentation explores the link between the groundwater extraction and the Earth's axial tilt shift and the story behind Greenland. We'll examine its scientific basics, the consequences for climate and ecosystem, and the call for considering broader environmental explication. Extensive extraction of groundwater, primarily agricultural and industrial purposes, has brought about changes in the distribution of Earth mass and impacting its rotational dynamics. This intriguing phenomenon underscores the intrigued relationship between humans' activities and the delicate balance of Earth's natural processes. Between 1993 and 2010, researchers have estimated that humans have pumped over 2 trillion tons of water out of the ground. Earth's axis underwent an annual shift of approximately 10 centimeters during the 20th century, as reported by NASA. As the Earth rotates, its rotational poles defined by the axis passing through the planet's crust, as this is a natural shift. Nevertheless, various factors, including ocean currents, movement of melting rock in the mantle, and glacial melting due to the climate change, can influence the distribution of mass and include and induce axis drift. The presence of water in man-made reservoirs and fluctuations in atmospheric winds also contribute to these dynamics as detailed by the research authors. However, the movement of the planet's poles isn't solely contributed to through climate change. According to a recent study, the period from 1993 to 2010 witnessed an estimated pole shift of approximately 80 centimeters due to the extraction of groundwater and subsequent sea level rise, both of which are influenced by human activities. Here, in fact, researchers employed a computer model to examine the influences of various factors on the pole shift phenomenon. When groundwater extraction was not incorporated into their model at the beginning, their projection did not align with the observed extent of pole movement by scientific measurements. However, upon considering the substantial volume of pumped water, which exceeding 2 trillion tons from 1993 to 2010, as mentioned before, the model correlated with the actual observation within the real world. Here, based on this analysis, the researchers have calculated that the axis is undergoing a displacement of about 4.3 centimeters annually due to groundwater extraction among the various factors examined in the study. The pumping of groundwater emerged as the second most significant influencer in the shifting of the axis, with the melting Greenland ice sheet ranking as the primary contributor. Take a look at Greenland. The blue marking are the melting sheets of ice. These ponds are expanding and becoming more of a lake, along with lakes that are becoming visible, which are expanding through the melting of ice sheets. Here you would see the outnumbered ice sheets in the gallery, as it is undergoing gradual fragmentation over time, attributed to a range of contributing factors, as we have mentioned recently. These two pictures are observed of the visible ice sheets that are being fragmented through time. Ice collapsing of Russell Glacier in Greenland. Researchers are in consensus that melting of ice sheets in Greenland will result in a minimum of 7.6 centimeters of global sea level increase by the conclusion of this century. A close-up view of melt water from Greenland's Russell Glacier, the drains of Greenland's ice sheets. According to a recent study published by USA Today, Greenland melt ice sheets of more than 100 trillion ton will cause a sea level rise of at least 27.4 centimeter. Surinder Alkiri, a geologist at NASA Jet Propulsion Laboratory, who was not involved in the study, however, conveys to science Ron Cornwell, the way the planet wobbles is impacted by our activities. It is, in a way, mind-boggling. Ki-won Soo, a co-author of the new study and a geologist at Seoul National University, tells Nature News David Castellucci, every mass moving around on the surface of the Earth can change the rotation axis. Influence of groundwater removal on polar drift. As a polar drift, the removal of groundwater from locations situated at the Earth's mid-latitudes, exemplified by Jones Lake, USA, and India, holds a substantial influence. This impact surpasses that of groundwater extraction carried out at the equator or the poles. Remarkably, despite this pronounced effect, it is noteworthy that a significant portion of groundwater pumping has taken place within these high-impact zones. This prevalent pumping activities in such regions has resulted in a more pronounced impact on the Earth axis, as highlighted by Wilson in his conversation with new scientist James Deneen. Influences on sea level rise, groundwater extraction and its impact on ocean levels. Researchers conducted previously has approximated that the withdrawal of groundwater, which eventually finds its way into the oceans, was responsible for a sea level increase of 6.2 millimeter, spanning the period from 1993 to 2010. During the interval also between 2006 and 2015, the Earth experienced an average annual rise in global sea levels of approximately 3.6 millimeter. The latest study affirms that the extraction of groundwater has significantly contributed to this sea level rise phenomenon. The quantification of historical polar motion driven by climate factors was accomplished through the utilization of computational models, focusing on terrestrial water storage dynamics under distinct two scenarios. The first one of these scenarios hinged on the integration of GRACE and reanalysis data. The second one was the scenario incorporated additionally observations related to glacier changes, notably the accelerated decrease in terrestrial water storage attributed to the melting of ice in glacier regions, exerted as this pronounced influence on the eastward drift of polar motion during the 1990s. This intricate analysis, which shed light on the relationship between climate-induced processes and the Earth rotational dynamics. Multiple factors are under consideration among data collection and beyond. This will include glacier isostatic adjustment (GIA), atmospheric change, oceanic effect, hydrological changes (TWS). The following list will include data that supports the case study. Here are the notable mentions within the case study. The data for alteration of Earth axial tilt caused by extensive groundwater extraction is correct as of 31st August 2023. That concludes today's case study. Alternatively, you have the option to view a brief clip shedding light on the concealed mysteries of Greenland. This credited by Seeker from research climatologist William Colgan.
This team of scientists and engineers are camped above an abandoned Cold War military base that's buried 30 meters below Greenland's ice sheet.
That is Delta storm condition.
They're part of a special climate monitoring program because the underground base that they're studying could eventually thaw out and unearth thousands of tons of toxic waste.
On the top top of the world, below the surface of a giant ice cap, a city is buried. This is the story of Camp Century.
During the early years of the Cold War, the U.S. started paying close attention to Greenland. To protect the island from creeping Soviet influence, the U.S. and Denmark signed the 1951 Defense of Greenland Act.
Today, on the island of Greenland, the United States Army has established an unprecedented nuclear-powered Arctic Research Center.
Army personnel put the latest advances in polar construction to the test, building several military bases out on the ice sheet. One of them was Camp Century.
We finally picked this plateau, a smooth white plain of ice for as far as you could see. This was the closest location to Thule, our supply base, which would not be affected by the summer thaw.
Researchers were doing a lot of very fundamental glacier and climate research. Camp Century is probably best known for being home of the first deep ice core to the bed of the Greenland ice sheet. It's like nothing we have today. It was just this phenomenal marriage of technology and innovation in the 1960s.
They built an entire underground city, complete with housing, kitchens, lounges, scientific labs, a chapel, and even a barbershop.
And the whole camp, which could house up to 200 people on a year-round basis, was powered by a nuclear power plant.
The U.S. Atomic Energy Commission invested a ton of R&D into small, portable nuclear power reactors that could be built in remote locations, and Camp Century was the perfect proving ground. The U.S. flew over 400 tons of equipment to Greenland to build a PM2A reactor, and they carefully transported the materials to the base, where scientists then installed it to power the polar camp.
Now here it is, with all 5 control rods withdrawn 6.24 inches, PM2A when critical at 0652 hours.
Camp Century was presented to the world as a heroic conquest of the Arctic in man's never-ending pursuit for knowledge and scientific progress.
They had Walter Cronkite up there doing NewsHour specials back in the 60s. Everybody knew about it. It was no secret.
But this scientific endeavor was actually part of a covert U.S. Army operation, codenamed Project Iceworm. In response to escalating Cold War tensions, the U.S. wanted to position 600 medium-range missiles with nuclear warheads underneath the Greenland ice sheet. All was going according to plan until engineers noticed the ice that surrounded the base was shifting faster than initially projected.
The people who were working at Camp Century did not have an understanding of climate change. They didn't have satellite records, global climate models, these sorts of big data sets that let you see an overview of what's happening to Earth's climate.
The moving ice sheet started to destabilize the underground tunnels, prompting the U.S. Army to abort Project Iceworm.
When Camp Century was decommissioned, only the nuclear reactor was taken out for destructive testing, and the rest of the camp was left in place. And they closed the doors and left. It was abandoned on the assumption that climate wouldn't change, and it would continue to snow at Camp Century forever. And the perpetual snowfall would entomb all of the base infrastructure and eventually bury it.
But the climate has changed. Temperatures have reached record highs in the Arctic, and Greenland's ice sheet is melting at an unprecedented rate, which could turn Camp Century's abandoned waste into a major environmental risk. So, a team of scientists, including William, went back to the site.
In 2017, the government of Denmark, at the request of the government of Greenland, started the Camp Century Climate Monitoring Program. We set up a bunch of instruments that are erected on the ice sheet surface, and then we drill in and we put probes into the ice sheet. It keeps a real-time data stream coming from the Camp Century site, where we monitor a bunch of things, mainly the temperature of the snow, the temperature of the ice, the air temperature, properties that'll help us sort of model how the snow and ice at Camp Century is going to behave over the next century.
They also mapped the debris left behind using ice-penetrating radar.
The radar is perhaps the most time-consuming. You have to manually tow it at a slow speed. It sends out a pulse of energy that goes down into the ice, and then it reflects off different things. It comes back to a receiver. It was 80 kilometers in total. That was a lot of radar.
They turned those radar profiles into a 3D map of the entire debris field.
At Camp Century, you get those horizontal lines of annual accumulation layers, but then you also get these big pockets of chaos. You can see the main tunnels. You can see pieces of debris down to about the size of a vehicle, maybe even a fuel drum. Our preliminary estimate is that we think the debris field is about 55 hectares in size, which is about 100 football fields, and we think it contains just over 9,000 metric tons of debris. We're very interested in how deep everything is and where it is, so that when we go to do our simulations of how much meltwater there might be at the site over the next century and how deep it is going to percolate into the ice sheet. There's concern that if meltwater starts interacting with the debris field, it could mobilize some contaminants.
Those contaminants include diesel fuel, nuclear waste like radioactive coolant water, and other toxic chemicals from the camp's buildings and general infrastructure. And all of that is on track to seep into the environment.
In the 1960s, the building codes were a little different. So we know, for example, that the materials they were using at Camp Century were rich in PCBs and other types of persistent contaminants. They still come out of the ground kicking. I mean, they don't deteriorate at all. We're sort of at a fork in the road for Camp Century. Under the business as usual climate, it looks likely that we will start to see more melt than snowfall at Camp Century by the end of the century. But if we stick with something like Paris Agreement, we can keep more snowfall than melt beyond the end of the century.
This raises questions about who is ultimately responsible for the cleanup, and that leads us into a geopolitical gray area. Camp Century was a U.S. base on Greenland soil, which was governed by Denmark. Currently, no party has taken responsibility for the abandoned base. And international environmental law really hasn't figured something like this out yet.
It's really a microcosm of the multi-generational, even multinational implications of climate change facing us now. And we have to be very aware of future projections and take action today to go on the high mitigation and low emissions route.
For more science documentaries, check out this one right here. Don't forget to subscribe and keep coming back to Seeker for more videos.